Hello, 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 hello. Hey guys, this is the lecture number 5 of quadratic equation. We have already completed till lecture 4 of quadratic equation. In that particular lectures, we have solved many examples of quadratic equations, and also we did a lot of theories related to the quadratic equations, right? So in this particular video, we will trying to solve a lot of questions which actually asked in the previous years of JEE Mains and JEE Advanced, right? So this particular lecture is only for problem solving, which we have already did in the lecture 4, right? So let's start the video with showing you one of the very nice questions which I actually give you for your homework, right? So let me discuss about this problem and the solution so that you can match with your solutions whether that is correct or not. Okay, so let's read this particular questions, what the question actually trying to say, right? Let alpha and beta be the roots of the equation x square minus 6x minus 2 equals to 0, right? So we have to first write down the given equation. We have to first write down the given equation, which is x square, which is x square, sorry, this particular color is not visible enough. Yeah, okay. Let me write down this particular equation, which is x square minus 6x plus, sorry, minus 2, which is equals to 0, right? This is the question which given to us, right? So we have to solve this question. So first of all, alpha and beta be the roots of the quadratic equation, which is x square minus 6x minus 2 equals to 0, right? Let me first change the color, which is more visible enough to. Wait a second, please. Uh, yeah. Okay. The question says that let alpha and beta be the roots of the quadratic equation, which is x square minus 6x minus 2 equals to 0, right? So if an equals to alpha to the power n minus beta to the power n, for n greater than 1, greater than or equals to 1, then the value of a10 minus 2a8 by 2a9 is equals to, right? This is literally very lengthy, but let me first find out the roots of the quadratic equation, right? So the given quadratic equation is the given quadratic equation is x square minus 6x minus 2 equals to 0, right? So let us apply the Sridhar formula. So after applying the Sridhar formula, what we have? We have x equals to, I'm not discussing the basic of Sridhar formula, I'm just solving this particular problem as much as early I can do, right? So minus b, so it will be minus of minus 6 plus minus root under of b square. So here b is nothing but minus 6, so b square minus 4ac, c is minus 2, right? B square minus 4ac upon 2a, right? 2 times 1. So it will be 6 plus minus root under minus 6 whole square will be 36, and minus times minus will be plus, and 4 times 1 times 2 will be 8, right? Upon 2. So the value will be 6 plus minus, if we calculate this particular term like 36 plus 8, it will give us 44, right? Upon 2. So we can write down this 44 as plus minus 2 root 11, right? Upon 2. So after cancelling these two, after taking common and cancelling this numerator and denominator by 2, what we'll have 3 plus minus root 11, right? So what we have, x equals to 3 plus minus root 11. So what are the values of x? I mean the roots of x, roots of the quadratic equation, which is 3 plus root over of 11 and 3 minus root over of 11, right? And it is given that alpha and beta be the roots of the quadratic equation, right? So let alpha equals to the first root, which is 3 plus root 11. You can take the second root as alpha, that there will be no issue, and beta equals to second one, which is 3 minus root 11, right? And here it is given that an equals to alpha to the power n minus beta to the power n, right? So given that, given that an equals to alpha to the power n minus beta to the power n, right? So if we put the value of alpha and beta here, we will have an equals to 3 plus root 11 to the power n minus 3 minus root 11 to the power n, right? We will have the value of an like this, right? So then we have to find out the value of A10 minus 2A8 by 2A9, right? So here you can see that basically we have to try to find out what is the value of A10, what is the value of A8, what is the value of A9, right? Since we have an equation of, we have a sequence of an, which is n equals to 3 plus root 11 upon n, 11 to the power n minus 3 minus root 11 to the power n. So if we substitute n equals to 10 here, we will get a10 equals to, obviously we have to put 10 instead of n. So it will have 3 plus root 11 to the power 10 minus 3 minus root 11 to the power 10, right? Similarly, if we put n equals to 8, we will have a8, which is equals to 3 plus root 11 to the power 8 minus 3 minus root 11 to the power 8, right? Similarly, if we put a9, then we will have 3 plus root 11 to the power 9 minus 3 minus root 11 to the power 9, right? So these are the all a10, a8 and a9s are. So we have to substitute these values in the particular given values, which is a10 minus 2 a8 upon 2 a to the power 9 a9, right? So let me first erase all these things so that you can so that we'll have more spaces to do the work, right? Yeah, we have to erase all these things. Wait a second, please. Yeah, so let me first erase these things. This is literally very important for me. Yeah, okay. So okay, so let me first write down what we have to find out, which is a10 minus 2a8 upon 2a9, right? So let's put the values, right? So after putting the value, we will have 3 plus root 11 to the power 10, right? Minus 3 minus root 11 to the power 10, right? So let me write down minus 2 times of 8, right? 8 will be 3 plus root 11 to the power 8, right? Minus 3 minus root 11 to the power 8 upon 2 times a9. A9 will be 3 plus root 11 to the power 9 minus 3 minus root 11, 3 minus root 11 to the power 9, right? Okay, so after calculating this, it looks like very difficult, but it will be very easy after doing this type of calculation. Let me first break this part, right? So it will be 3 plus root under 11 to the power 10, right? Minus 3 minus root under 11 to the power 10. After multiplying this by 2, we'll have 2 times 3 plus root under 11 to the power 8, and minus times minus will be plus times 2 times 3 minus root under 11 to the power 8, and the denominator will be 2 times 3 plus root 11 to the power 9 minus 3 minus root 11 to the power 9, right? We have to follow some basic calculations so that this question will be looks very simple, right? Let's see that this particular part and this particular part has a relation. Like here you can see 3 plus root to the root over of 11 to the power 10 is there, and here we have 3 plus root over of 11 to the power 8, right? So from these two values we can actually take common, which is 3 plus root 11, which is 3 plus root 11 to the power 8, right? Because this is the lowest value. So after taking common, we'll have, let me first clear all these things because we need some more spaces to solve this particular, question, right? So let me first erase all these things, which is not needed right now. Okay, so let me erase all these things. Yeah. So if we calculate this particular part, so here you can see that this part and this part has a relation, right? So if we take common 3 plus root under 11 to the power 8, so what we'll have 3 plus root 11 square minus 2, right? And if we see this part and this part, there is also a relation, like 3 minus root to the power 11 and 3 minus root to the power 11 will be the common part, right? So if we take common, minus 3 minus root under 11 to the power 11 to the power 8, so what we'll have basically 3 minus root 11 square, and it will be minus 2, right? So here you can see basically I'm just taking common from there and there, right? And the denominator part will be as it is. We have to write down the denominator part as it is, because if we break all these parts it will be very lengthy and we will face a lot of difficulties to solve this particular question, right? So let me write down this part as it is, which is 3 plus root under 11 to the power 8, and let me break that part, which is a plus b whole square. So it will be a square, I mean 3 square, so it will be 9 plus 2 times 3 times root 11, it will be 6 root 11, and plus root over of 11 square, that will be only 11, and minus 2 is there, so you have to write down minus 2 here, right? Negative of 3 minus root 11 to the power 8 times a minus b whole square. So it will be a square minus 2ab plus b square. So 3 square will be 9 minus 2 times 3 times root 11. So it will be 6 root 11 plus root under 11 whole square. That will be only 11 minus 2, right? And the denominator part will be 2 times 3 plus root under 11 to the power 9 minus 3 minus root under 11 to the power 9, right? So let me erase that part so that I have more spaces. Yeah, so let me erase that part. So wait a second, please. Yeah, right. So yeah, so this we'll have. So after calculating that part, what we'll have, basically we'll have 3 plus root under 11 to the power 8 times, here you can see 11 minus 2 will be 9, 9 plus 9 will be 18, right? So 18 plus 6 root 11 is there, and minus 3 minus root under 11 to the power 8 times 9 plus 11 will be, here you can see 11 minus 2 will be 9, and 9 9 18, right? So 18 minus 6 root 11 is there, right? And the denominator part will be 2 times 3 plus root under 11 to the power 9 minus 3 minus root under 11 to the power 9, right? So let me again calculate this part. So if we take common 6 from this particular area, this particular region, so after taking common 6, we will have basically 3 plus root 11 to the power 8, that part is there, and we will have 3 times root under 11, right? 3 times root under 11, and the 6 is there. Similarly, if we take common 6 from there, so it will have 6 times 3 minus root under 11 to the power 8 times 3 minus root under 11, right? And the denominator part will be 2 times 3 plus root 11 to the power 9 minus 3 minus root under 11 to the power 9, right? So here you can see that the value will be 6 times, here you can see 3 plus 11 to the power 8 is there, and 3 plus 11 to the power nothing is matlab 1, right? So 1 is there. So if we write down this particular part in one part, it will be 3 plus root 11 to the power 9, right? Minus 6 times. Similarly, if we write down this part, we can write down this part as 3 minus root 11 to the power 9, and the denominator part will be as it is, which is 2 times 3 plus root 11 to the power 9 minus 3 minus root under 11 to the power 9, right? So here we can take common 6, right? So after taking common 6, we will have 3 plus root under 11 to the power 9 minus 3 minus root under 11 to the power 9, and the denominator part will be 3 plus root under 11 to the power 9 minus 3 minus root under 11 to the power 9. So we can cancel this part. Here you can see, right? So that is why I'm always trying to say that don't break this part into binomial expansion, because if you break this part, it will be a very lengthy question, and you may not solve this particular question by following this path within the time, right? So the value will be 6 upon 2. So if we apply the if we divide this part, it will have only 3, right? So the answer will be 3. So here you can see that option number A will be the correct option. So I think you can understand what am I trying to solve this particular, what am I trying to uh, apply these formulas. Basically, here you can see that let alpha and beta be the roots of the equation, which is x square minus 6x minus 2 equals to 0. So this equation, this quadratic equation is given to you, right? So you have to apply the Sridhar Acharya's formula, through which you will be able to find out the roots of the quadratic equation, and the roots will be 3 plus root 11 and 3 minus root 11, right? So after that, you can take alpha equals to 3 plus root 11 and beta equals to 3 minus root 11. You can take alpha equals to 3 minus root 11 also. There is no issue, right? So we took alpha equals to 3 plus root 11 and beta equals to 3 minus root 11. After that, we have to find out the value of an, which is nothing but 3 plus root 11 to the power n minus 3 minus root 11 to the power n, right? So then we have to put n equals to 10, n equals to 8, n equals to 9, because we have to find out the value of a10, a8, a9, so that we can find out the total value of a10 minus 2a8 upon 2a9, right? So we found out the value of a10, a8, a9, and after that we put the values, and we will do some calculations. Here you can see, and we will get the result, which is 3, right? So this is a very lengthy question, but this is also a very important question to understand, right? Okay, let's move to the next question. This is also a very important question, and also you will learn a lot of things from that question. So the question says the sum of all real values of x, the sum of all real values of x satisfying the equation x square minus 5x plus 5 to the power x square plus 4x minus 60 equals to 1, right? So let me write down this equation, which is x square minus 5x plus 5 to the power x square plus 4x minus 60 equals to 1, right? So we have to find out the sum of all real values of x which satisfying this equation, right? So here you can see that particular equation is of the form a to the power b equals to 1, right? Where a is nothing but x square minus 5x plus 5, and b will be nothing but x square plus 4x minus 60, and which is equals to 1. So can you tell me, let me write down here a, which is a to the power b equals to 1. So can you tell me for which values of a and b that particular case, which is a to the power b equals to 1, has value 1? Suppose we can put a equals to 1. Suppose we can put a equals to 1. So for the case of a equals to 1, 1 to the power b will be 1. There is no issue, right? Suppose if we put a equals to -1, then what will happen? Left hand side will be -1 to the power b, right? Then that part will be 1 only when b will be negative, b will be even, right? Suppose if b will be odd, then -1 will be outside of the expression, right? So that will not become 1. So b should be even, right? And we can take b equals to 0 also. For b equals to 0, a to the power 0 will definitely 1, right? So there are three conditions. One condition is a equals to 1, right? Second condition is a equals to -1, then b must be even, right? B must be even. And the third condition is for b equals to 0, right? So here you can see that there are three conditions for which a to the power b equals to 1 will be satisfying, right? This particular equation will be satisfied for these particular three conditions, right? So let me erase that part so that I can give you what are the ideas for which we'll get the solution, right? So we have to first put that particular part equals to 1, right? So let me put for x square minus 5x plus 5 equals to 1, right? So for that reason we will get x square minus 5x plus 5 to the power x square plus 4x minus 60, which is equals to 1, right? So let me calculate this part, which will be x square minus 5x plus 5 minus 1, which is nothing but 4 equals to 0. So we can write down this particular equation as x minus 4 times x minus 1 equals to 0. So the roots will be either x minus 4 equals to 0 or x minus 1 equals to 0, right? If we put x minus 4 equals to 0, we will have x equals to 4. If we put x minus 1 equals to 0, we will have x equals to 1, right? So what values of x we will have, which is 4 comma 1, right? So let me write down the values of x, which is for x equals to 1 we will have x equals to 4 comma 1, right? Let me write down this particular thing. Okay, let me write down the second equation, which is for x square minus 5x plus 5 equals to minus 1. Then definitely x square plus 4x minus 60 must be even, right? So let me solve this particular equation, which is x square minus 5x plus 5 plus 1. It will be 6 equals to 0. So what we can solve this particular question with x minus 3 times x minus 2, which is equals to 0, right? From this x minus 3 we will have x equals to 3. From this particular x minus 2 we will have x equals to 2, right? After putting x minus 3 equals to 0 and x minus 2 equals to 0, right? So we will have two values of x. One is 3 and another is 2, but we must have to take the even values only, right? We can't take odd values. So 3 will not be acceptable values, 2 will be acceptable values, right? So we have to do x equals to 2. So let me write down for x equals to minus 1 and the part should be even, we'll have only one value, which is x equals to 2, right? So similarly for x square plus 4x minus 60 equals to 0, right? If the upper part here you can see, right? If the upper part will be 0, then something to the power 0, like something not equals to 0 to the power 0 will be definitely 1, right? So let me solve this particular part. Suppose we can solve this by let me think about it. We can solve this by x square plus 10x minus 6x minus 60 equals to 0, right? We can write down 4x as 10x minus 6x minus 60. That minus 60 is there. So if we take common x from these two relation, we'll have x plus 10 minus 6 times x plus 10, right, equals to 0. So let me take common x plus 10 from there. So we will have x plus 10 into x minus 6 equals to 0, right? Similarly, if we put that part equals to 0, so we will have x equals to minus 10. And if we put that part equals to 0, so we will have x equals to 6, right? So for x square plus 4x minus 60 equals to 0, we will have two values of x. One is minus 10 and another is 6, right? So let me first write down here, which is for x square plus 4x minus 60 equals to 0, we will have x equals to minus 10 comma 6, right? So let me erase that part so that I can write down all these things. Yeah. So let me erase that part. Yeah. So here you can see what values of x we will get after solving this particular equation. One is x equals to 4 comma 1, another is x equals to 2, right? And another is x equals to minus 10 comma 6, right? So this is for x square. Sorry, this is for x equals to 1. I can write down this as x square minus 5x plus 5, right? X square minus 5x plus 5 equals to 1. This is not x equals to 1. First of all, let me clear on this thing. Let me clear this part. Yeah. So this is for x square minus 5x plus 5 equals to 1, and this is for x square minus 5x plus 5 equals to minus 1, right? And x square plus 4x minus 60 should be even. This is what we have already discussed, right? So this is for x square minus 5x plus 5 equals to 1. This is for that part is equals to minus 1 and even part. And this is for x square plus 4x minus 60 equals to 0, right? So here you can see that we will have 5 values of x. So the question is the sum of all real values of x satisfying this equation is. So we have to take the sum of these values, right? We have to take the sum of these values. So let me summing all these values. So it will be 4 plus 1 plus 2 plus minus 10 plus 6, right? So it will be 4 plus 1 will be 5, 5 plus 2 will be 7, 7 minus 10 will be minus 3, minus 3 plus 6 will be 3, right? So the correct option is C, right? Here you can see. So C will be the correct option. So you can understand how much depth knowledge you must have to solve this particular question, right? It will be very difficult for you to understand these problems, but after thinking more about this problem you can definitely solve these questions. It will take some time, but there will be one day when you can easily solve this question. So don't be depressed after seeing this particular solution. Uh, but you have to take the motivation that there are some questions which have a lot of depth knowledge behind that, right? It may look very simple, but it is not actually. The internal concept may be very difficult, right? Yeah. So let's move to the next questions. And this is also a very logical question, and you may be feel very nice when you solve this particular question. The question says the equation x minus 2 upon x minus 1 equals to 1 minus 2 upon x minus 1 has no root, one root, two equal roots, and infinitely many roots, right? So let me first give you 1 minute for think about these questions. After that I will give you the solution of that question. So please think about this question. Okay, uh, let's start the solution. I think you may think of about the solution. So let's start the solution, right? So here the given equation is given equation is x minus 2 upon x minus 1, which is equals to 1 minus 2 upon x minus 1, right? So sometimes student says that, sir, we can neglect this particular two part, because here minus 2 upon x minus 1 is there and minus 2 upon x minus 1 is there. So that will be cancelled out when x minus 1 will not equals to 0, right? Let me clear one thing, that x plus, suppose a by b is there, and on the right side it will have y plus a by b, right? So a by b and a by b will be cancelled out when b should not be equals to 0, right? That is very important, because if b equals to 0, then a by b will be undefined, so undefined part will be not negligible, right? So that will be cancelled out, so that will be cancelled out. uh, Minus 2 upon x minus 1 will be negligible, or you can say cancelled out from both sides when the denominator part, which is x minus 1, is not equals to 0, right? If x minus 1 will be 0, then we can't cancel out this part, because that will be undefined, right, relation. So from x minus 1 not equals to 0, we will have x not equals to 1, right? That is a very important condition which you have to remember, right? So let me write down this particular equation as star, right? So x should not be equals to 1. So star we have from star, you can see x equals to 1, right? So sometimes student says that since x equals to 1, so one root will be the one root will exist for that equation. So that is not correct option, because from the relation we have already see that x should not be equals to 1, but after cancelling that part we will get the value of x, which is 1. So this contradicts the fact that this particular equation have a root. This contradicts, right? So this particular equation have no root, because if we take x not equals to 1, then that part will be cancelled out, but after cancelling that part we will have x equals to 1. So we should not take x equals to 1, right? So that particular equation has no root, so you can understand, right? This is a basic example, but have a lot of in-depth knowledge, right, of real numbers, have an in-depth knowledge of real numbers, right? So let me move to the next question, which is also very important question, and this is a question of you can say in inequality, right? This is not a quadratic equations questions, but sometimes you can say it is a question of inequality, right? So let me solve these questions. So here it is says that if S is the set of all real x, if S is the set of all real x such that 2x minus 1 upon 2x cube plus 3x square plus x is positive, then S contains some interval is given to you, right? A is an interval which contains minus infinity to minus 3 by 2 open interval. Here you can see B option is actually minus 3 by 2 comma minus 1 by 4 open interval. Similarly, open interval of minus 1 by 4 comma 1 by 2, and the D option is open interval of 1 by 2 comma 3, and the E option is none of these, right? So let me first write down this equation, which is let me use the white color, because white is actually more visible, right? So 2x minus 1 upon 2x cube plus 3x square, right, plus x, right? And we have to find out S is the set of all real x such that this particular expression is positive, right? So this is greater than 0, so that is why it is positive, right? So here we can write down this part as 2x minus 1. First of all, let me clear one thing. This is a question of inequality, but we can apply some of the form of quadratic equation. That is why these questions actually be a part of quadratic equation, right? Here you can see that 2x cube is there, 3x square is there, and x is there. So from these three relation, x is a common part, right? So we can take common x. So we will have 2x square plus 3x plus 1, right? Which is greater than 0. So 2x minus 1 upon x times, we can write down this particular equation as 2x square, right? Plus 2x plus x plus 1 greater than 0. So we will have 2x minus 1 upon x times, we can take common 2x from these two relation. So after taking common 2x, we will have x plus 1, and we can take common 1 from this relation. So we will have x plus 1, right? Greater than 0. So we will have 2x minus 1 upon x times x plus 1 times 2x plus 1, right? Greater than 0. I'm just taking common x plus 1 from these two relations. So we will have 2x plus 1, right? So let me erase all this part so that we can solve this particular thing, right? Yeah. Okay. So we have that relation, right? So the let me write down this particular equation, which is 2x minus 1 upon x times x plus 1 times 2x plus 1, which is greater than 0, right? So the main motto should be that x is actually coefficient free. I mean, the coefficient of x would always be 1, right? Here you can see the coefficient of x is 1, here the coefficient of x is 1, but here the coefficient of x is 2 and the coefficient of x is 2. So we have to divide by 2 from these two relation, right? We have to divide by 2. So we will have 2x minus 1 by 2 upon x times x plus 1 into 2x plus 1 upon 2, right? We can write down this. We can write down this, which is greater than 0. So if we divide this part, the numerator will become x minus half, and the denominator will have x times x plus 1 times 2 will be in that particular range. So in that particular 2 will be with 2x plus 1, so it will have x plus half, right, equals greater than 0. So if we just write down the real axis, and if we just putting all the factors equals to 0, so what we will have, if we put x minus half equals to 0, so we will have x equals to half, right? If we put x equals to 0, we will have x equals to 0. If we put x plus 1 equals to 0, we will have x equals to minus 1. If we put x plus half equals to 0, we will have x equals to minus half, right? So let me plug in all these values in the real axis, on the real axis. So let me write down this as 0. So minus 1 will be somewhere around there, and minus half will be middle of minus 1 to 0, and half will be there, right? And by uh, and by you can say some inequality formula, we can see that that particular polynomial expression or that particular function will be positive for all values of in the range of half to infinity, right? This is infinity and this is minus infinity, right? Similarly, that part will be negative, that part will be positive, that part will be negative, and that part will be positive, right? So can you tell me which part has actually positive values, gives positive values? That part and that part, right? So let me clear that part, right? Let me clear this thing. Yeah. So since all these parts are actually positive, so we can write down x belongs to minus infinity to minus 1, right? Minus infinity to minus 1 union minus half to 0, right? Minus half to 0 and union half to infinity, right? Because in that particular region, that particular function will give positive values, right? So let me check the options. So in the first option, you can see that S contains S, this is the set S, right? This is the set S, right? This is the set S. So does minus infinity to minus 3 by 2 contains in that particular set? Let me check. Minus 3 by 2 is nothing but minus 1.5. So minus 1.5 somewhere around there, right? There is minus 1.5. So since you can see that from minus 1.5 to in minus infinity, all the parts are positive. So that part will be the correct option, because minus infinity to minus 3 by 2 lies in this particular set, right? Lies in this particular set. Let me check. Minus 3 by 2 to minus 1 by 4, right? So here you can see minus 1 by 4 somewhere around there, right? So and minus 3 by 2 is there. So in minus 3 by 2 to minus 1 by 4, there is a part which contains negative, right? Negative symbols, and that part is not belongs to in that particular set. So B option will not be the correct option. Similarly, if we check the C option, then you can see that 1 by 4 to 0, 1 by 4 to 0 contains only positive values, and that also belongs to, and that also be a part of this particular set, right? So C option will be the correct option. But in the case of D, let me see again, like, um, yeah, let me see again, please. Wait a second. That minus 1 by 2 is there, so definitely minus 1 by 4 will be there, and we have to take minus 1 by 4 to half, minus 1 by 4 to half, right? So in that particular range, here you can see from 0 to half, there is negative symbols, right? And that part is not be a part of this particular set, so that part doesn't contained in S, so this will not be a correct option. And for the case of D, here you can see 1 by 2 to suppose 3 is there, right? So 1 by 2 to 3 contains only positive values, and that contains in the set S. So D will be the correct option. So A and D will be the correct option, but B, C, and E options are the not correct options, right? So this is also a very important questions which you have understand, right? So let's move to the next question, which shows you like for a less than or equals to 0, determine all the real roots of the equation x square minus 2a times x mod of x minus a minus 3a square equals to 0, right? So here you can see that the given equation is x square minus 2a mod of x minus a minus 3a square equals to 0, right? So I have already told you that we can break the mod function into basically two parts. So basically if mod x is there, so mod x can be written as x if x is greater than or equals to 0, right? And mod x will be minus x if x is less than 0, right? Sometimes student can express this mod x into three parts, which is x if x is greater than 0, 0 if x equals to 0, and minus x if x less than 0, right? So here we have to break this mod function, which is mod of x minus a into two parts, which are basically mod of x minus a will be x minus a if the internal part, which is x minus a, will be greater than or equals to 0. I'm just taking this particular form. This is also right because these are two similar parts, these are isomorphic, so there is no issue, right? And minus of x minus a when x minus a will be negative, right? X minus a will be negative. So let me write down these things again. X minus a will be there if x greater than or equals to a, and it will be minus x minus a will be there if x less than a, right? Yeah. So let me clear that particular part. Okay. So let me write down this particular equation, which is given as x square minus 2a mod of x minus a minus 3a square equals to 0, right? So for x minus a greater than or equals to 0, right? So I mean that is x greater than or equals to a. So if x minus a is greater than or equals to 0, then mod x minus a will be break as x minus a. So that particular equation will form x square minus 2a times x minus a minus 3a square equals to 0, right? So it will be x square minus 2ax plus 2a square minus 3a square equals to 0, right? So it will have x square minus 2ax minus a square equals to 0, right? So this equation we will have. So let me apply the Sridharacharya's formula. So which will be x equals to minus b. So it will be minus of minus 2a. That means 2a minus b plus minus root under of b square. I mean minus 2a whole square. So it will be 4a square, right? B square minus 4ac. I mean 4 times 1 times minus a square, right? So it will be minus 4a square, and here minus is also there. So it will be plus 4a square. You have to calculate something in your mind also, because that will save you a lot of time at the exam hall, right? So it will be 2a plus minus, it will have 8a square upon 2, right? So the value will be 2a plus minus 2 root 2a upon 2, right? So x equals to, if we take common 2 from the numerator, it will have a plus minus root 2a upon 2. So if we cancel this part, we'll have a plus minus root 2a, right? So the values of x will be a plus root 2a and a minus root 2a, and I'm saying that these two values are the acceptable values. These two values are the acceptable values because the condition is given to you is a less than or equals to 0. I mean a is either 0 or a is less than 0, and from that condition we will get x minus a greater than or equals to 0. So that means x is greater than or equals to a, right? So let me give you a home task, which is you have to see why these two values are actually acceptable values, and also you have to check whether this, by using these conditions, why these particular values are the acceptable values, right? So your homework is like that. So check why these values are acceptable by these two conditions, right? So this is the roots. So let me erase that part for the next next part, to solve this next part. Yeah, so let me erase that part. Yeah, okay. So let me say for x minus a is less than 0. Definitely if x minus a is less than 0, then x less than a will be there. If x minus a is less than 0, then definitely x will be less than a, right? You can understand. Yeah. So if x is less than a, then a mod of x minus a will break by minus of x minus a. Then the equation will become x square minus of 2a times minus of x minus a minus 3a square equals to 0. So it will have x square minus times minus will be plus 2a times x minus a minus 3a square equals to 0. So it will have x square plus 2ax minus 2a square minus 3a square equals to 0, right? So it will have x square plus 2ax minus 5a square equals to 0, right? So I'm just giving you that particular part as your homework, that please try to find out the values of x by the same process what I actually did here, which is actually the Sridharacharya's formula. And after applying this particular formula, you will get the values of x, and you have to check whether these values are acceptable or not by that particular condition, right? By that particular conditions. So that's your task for your, that's your home task. Please, it is my request to check whether how much solutions you will get, right? So let's move to the next question. That is also a modulus functions questions, which is the set of all real numbers x for which x square minus mod of x plus 2 plus x greater than 0 is. So we have to try to solve this particular expression. It is a quadratic type of expression. So here the question is, we have to try to find out the solution of x square minus mod of x plus 2 plus x which is greater than 0, right? So let me first write down for x plus 2 greater than or equals to 0. I'm not defining all the modulus functions. I'm now actually solve this particular equation by the straightforward manner, right? So if modulus function, that means x plus 2 will be greater than or equals to 0, that is x is greater than or equals to minus 2, that modulus part will be break into plus x plus 2, right? Because x plus 2 is positive, right? Positive or equals to 0. So the equation will become x square minus x plus 2, because minus is there and that part will break into positive part. So x plus 2 will be there, plus x which is greater than 0. So x square minus x minus 2 plus x which is greater than 0. So minus x and plus x will be cancelled out, right? So because x is reals, right? So I can cancel this part. We have to find out the real numbers of x. So x square minus 2 is greater than 0. So we can actually apply something, the inequality form, which is, we can write down x square as x square minus 2 as root 2 whole square, right? Which is greater than 0. We're just trying to factor this particular expression. That is our main task in inequality, right? We have to try to factorize into linear form, right? So if we factorize them, it will have x plus root 2 times x minus root 2, which is greater than 0. So if we plot on the wavy curve, it will have minus root 2, because if we just applying this particular part equals to 0, right? For x plus root 2 equals to 0, x will have minus root 2. Similarly, if x minus root 2 will be 0, we will have x equals to root 2. So minus root 2 may be there, plus root 2 may be there, right? 0 will be somewhere in the middle of minus root 2 to plus root 2. But we don't need to write down this because we don't have any x as 0, right? So that part will be plus, that part will be minus, that part will be plus by wavy curve, right? Wavy curve method. You can check on the internet, right? And also I will give you the more clarity about wavy curve when we will discuss about the inequality part, right? So then x will become, since x is positive, so we have to take the positive part and positive part. So it will be minus infinity to minus root 2, minus infinity to minus root 2 union root 2 to infinity, right? Since it is strictly greater values, so we have to take the open interval, right? So x should be belongs to minus infinity to minus root 2 union open interval root 2 to infinity. But wait a second, here there is a condition, which is x greater than or equals to minus 2, right? So if x greater than or equals to minus 2, then x belongs to close interval minus 2 to infinity. You are already familiar with these topics, right? So here you can see one part is x belongs to close interval minus 2 to infinity, and another part is x belongs to minus infinity to minus root 2 union root 2 to infinity, right? So let me plot these particular intervals on the real axis. So some minus 2 somewhere around there, suppose minus root 2 is somewhere around there, root 2 is somewhere around there, right? So let me please take a horizontal line at there. So you can see here, you can see minus infinity to minus root 2 will be there, right? Sorry, minus infinity to minus root 2 will be there. It is minus infinity and plus infinity. Union root 2 to infinity will be there, right? And that region and that region, right? And minus 2 to infinity, minus 2 to infinity will be from there to infinite, right? From there to infinity, right? So that region. Can you see the common region? The common region will be that part union that part, right? So we can write down x belongs to minus 2, right? Minus 2, it will be closed interval because it exists and it actually cuts the line, right? So minus 2 to minus root 2 open interval because it ends here, but not the minus root 2 union union open interval root 2 to infinity, right? So this is the actual solution, this is the actual solution for that particular question when x plus 2 will be greater than or equals to 0, right? So let me understand this question. And also we have another case here. The another case will be, let me just erase that part, yeah. So the another case will be for x plus 2 less than 0. So for x plus 2 less than 0, we will have x less than minus 2. So if x less than minus 2, then we have x belongs to minus infinity to minus 2, right? And since it is strictly less than, so we have to take the open interval here, right? So if x plus 2 is negative, then mod of x plus 2 will break into minus of x plus 2, right? Mod of x plus 2 will break into minus of x plus 2, right? So this equation will be x square minus of minus x plus 2 plus x, which is greater than 0. So it will be x square plus x plus 2 plus x, which is greater than 0. So it will be x square plus 2x plus 2, which is greater than 0, right? So if we just applying this, it will be x square plus 2x plus 1. Let me break this 2 as 1 plus 1. You can understand why. Here you can see from this particular equation, we can write down this as x plus 1 whole square plus 1 greater than 0, right? Yes or not? So that particular part will be always positive, right? Yeah. So what will be the value of x plus, we can write down this particular thing, right? So this will be always positive. This will be always positive. And what we have to take? We have to take negative infinity to minus 2, right? We have to take negative infinity to minus 2. So can you please tell me what will be the solution of this particular case? Let me please trying to, let me please, so you can take your time so that you can understand what will be the solution of this particular part, right? So you can take your time and tell me what will be the solution. Can you please tell me? For any value of x less than 2, for any value of x less than minus 2, if we put here, that part will always positive or equals to 0. That part will always positive or equals to 0. Equals to 0 will not happen because minus 1 is not there. So that part will always positive, and that condition will satisfied for all real x. And here we have the condition x is less than minus 2. That means x belongs to minus infinity to minus 2. So this is the actual solution of that particular question, right? So we have x belongs to minus 2 close interval to minus root 2 union of root 2 to infinity, right? And we have another solution which is x belongs to minus infinity to minus root 2, right? So another solution is x belongs to minus infinity to minus 2. So let me just erase that part so that you can understand what am I trying to say, right? Wait a second, please. Yeah. So one solution is x belongs to that, and another solution is x belongs to that. So let me write down these solutions on the real axis. It will be, suppose this is minus 2 and this will be minus root 2. Similarly, that will be root 2, right? and minus 2 is there, right? Minus 2 is there. Okay, so this is suppose minus infinity and this is infinity, right? Let me write down the vertical lines here. Okay, so let me use another ink. So I have to take minus 2 to minus root 2, and minus 2 is close, right? So I'm just symbolically write down this and that. That means minus root 2 is not there, and that means minus 2 is there. That is why close interval is there, right? And also root 2 to infinity, right? So that will be like that. For that case, we will have minus infinity to minus root 2, right? So let me use another pen, which is suppose that color. It is minus infinity to minus 2, right? So if I just write down here, so it will be minus infinity to minus 2, right? So it is actually there, right? So you can see we have to take the union, because this is also solution, this is also a solution. So what is the exact solution? So since minus 2 to minus root 2 is there, and minus infinity to minus root 2 is there, so we have to take the union. I mean, we have to take the total part. We have to take the total part. Similarly, we have to take that total part also, right? So we have to take the total part, and we have to take the total part because we have to take the union, means all, right? So the solution of this particular question will become minus infinity to minus root 2, and that will be open interval, right? So minus infinity to minus root 2 union root 2 to infinity, and that will also be an open interval because here the symbol is actually not including root 2. So this is the actual solution. I can understand that you may have faced some difficulties to understand this particular solution of that question, but please try to analyzing all these important things so that you can easily understand what will be the uh, how actually the solution we got, right? So the option will be option number B, right? So option number B is the correct option. So that is all for the today's lecture. We will solve some of the questions which came in JEE Mains and Advanced in the previous years. We'll solve these questions in the upcoming lecture. Till then, stay tuned with our channel and also try to solve these questions. Okay. Thank you so much for attending this lecture, and we will meet soon. Thank you. Thank you.